So it is about web development and how should we actually go about web development. So so web development is all about how actually today we actually hear a lot about the web development and how actually things proceed. Uh, just give me a second. So we all understand what is web and web is a way of actually communicating and transmitting data over the internet using HTTP protocols. So HTTP protocol is a backbone of the web. We have to really understand what is HTTP protocol to understand how at the basic the web works. And the data is actually shared with two type of systems, and those are recognized as client and server. Of course, we'll be actually, if you're doing a web development, you'll be working either on the server side or the client side. So we need to understand how clients works and server works. Uh, that's the uh, kind of a main components of the web. Those are the main components of the web development. So, what is client? Client are the devices which actually request and renders the web content. So they request the data from the server and actually renders in some kind of an interface, and where actually the end user interacts with the those contents and UI. The major clients are browser, mobile apps, and desktop apps. Even though nowadays our desktop apps actually pull a lot of data from the servers through web, and they actually try to give us lots of updated informations. Uh, and then we have a server application that delivers web content and services to the client's request. So the server is kind of a main uh, component which receives the request, understand what is required by the client, and then do some processing on this at their end, and then delivers the final result, which can be used by client to uh, render it on the user interface. So I think main purpose is to understand client and server. You have to see how the communication works. So here we can try to understand on the right hand side we have a client, which is usually a web browser, and then we have a server. So the client is actually first needs to send a request via URL, and then server will actually send a response to the browser or the client, and they will actually client will render it uh, in a format the way it's been designed to present the information to the end user. And the behind the scenes actually servers interacts with a lot of services. It has a file service, it has a database and all those things. uh, but between, like, before we go how see and how actually web server works, you can see that the HTTP browser actually first sends the HTTP request via URL. So of course, when you send a request via URL, there is a kind of a domain name which we understand, but browsers understand IP addresses. So in between, there comes a domain name server, DNS server, which has the mapping of domain name with the IP address. And once the browser actually gets the IP address of the web server, then it actually sends the request to the server on that IP address. Then let's try to just understand what is URL. What are the URLs? So as I said, like, the communication over the web happens the using the HTTP protocol. You have a kind of a host name, and then you have a domain name. So this domain name is actually, this host name is optional nowadays. Some website you'll see they use www dot and some doesn't actually avoid it. But you surely need a domain name. Which site you want to go, whether you want to go to Google or you want to go to Yahoo or any other site, you'll type the domain name within the browser, and then of course the domain will actually land up you on the home page of the given service. But if you want to request a specific resources, you have to provide a full path. So you have a directory and then you have an absolute path of the file which you are requesting from the servers. So basically there are three parts. One part is protocol, which you'll be using to actually request the server. Then you have a domain name, and then you have a path of the resources which you are requesting. So you have a directory path and then absolute file name. Uh, so the URL which you'll be actually requesting from the server can actually process those URL in two types. Whether it's a static content or it's a dynamic content. What do you mean by static content? Static content is basically pre-built content, uh, and it is actually stored on the file system of the server, and it doesn't changes very frequently. uh, it changes only when someone tries to kind of an upload it. An example of static content is JS, HTML, CSS, MP3 video and images. These files actually doesn't changes very frequently and kind of a static. And you have a dynamic content. The dynamic contents are generated on the fly. URL usually maps to the server side code, and contents is generated dynamically for a given request, and the data which is actually posted to the server. And example of dynamic content is usually ASP. .NET pages, JSP pages, or PHP pages. And dynamic content usually actually generates the dynamic content by interfacing with various data store, whether it's a file system or database. And so let's try to understand this HTTP protocol. To understand the web, we need to actually understand what is HTTP protocol is all about. So there are two feature of HTTP protocols which kind of differentiates this it's from other protocol. So those two feature are stateless and it is text based. So when we say stateless, it means that the client will actually send a request to the server and say, hey, this is the URL and give me the resource for this URL. And client and server will quickly try to find out that resource on the server and then deliver it to the client. Once this cycle of request and response is completed, server has no idea about the subsequent request which is coming from the client. So server doesn't remember the client. So HTTP by itself protocol doesn't force servers to remember the client who is who. And to actually make it stateless, it is a stateless, but then we all know that when we try to log in, we provide username and password, and then after like our username password is authenticated, server remembers our subsequent request. So how does that happen? That actually happens because of other technologies built on the server, on the client, and on the clients. So usually servers tries to remember the client using cookies. So whenever server first request goes to the server, server says that, hey, this is the IP address which actually came to us, and this actually never. Then it's try to actually find out whether it is I have been processing this or not in the recent past. And how does it does that? It has HTTP protocol stateless, but this, on the server side, you'll have some stateful service which maintains the session, and session is the concept which actually exists on the server. And the client, on the client side, you will have cookies will be sent to the server, and the server will see from the cookie, it will try to identify uh, whether the session related to exist on the server or not. If it exists, then it will try to fetch certain data on from the server and then accordingly service the request. So because it is stateless, you have the concept of cookie and session. And then you have a text-based, it is a text-based protocol in the sense the data is not transmitted in binary format, but in transmitted in a text-based format, which makes it very vulnerable. So anyone actually who can actually sniff the HTTP packets can very easily understand what is getting transmitted. You can try various, if you've been doing the development, we have Chrome has the web development tool. If you hit F12, you will see and go to a request and response screen. There you will see the data which has been posted to the server and what server is transmitting. So it makes it very vulnerable. Because of that thing, lots of other technologies actually came in picture, which try to make it more secure. And one of them is HTTPS. So your HTTPS tries to encrypt your request and response, and only the authorized services will be able to decrypt it. So as you see here, the way HTTP request and response work, client will request a particular resource from the server. Server will kind of a map it to whether static or dynamic content. Based on static and dynamic content, if it is a dynamic script, it will try to fetch data from the database and try to build a response, and then after that it will send the request to the server. uh, so I think main thing here to understand is that uh, lots of communication happens between the server side, between the servers and client, and it is based on the request and response. And it is the data is actually requested through a URL. So lots of request and responses happening, lot of data nowadays actually getting exchanged between uh, client and server. Earlier, web pages or web apps used to be very simple, and they used to kind of just render minimal information. But nowadays, if you see, uh, the web pages are becoming more and more rich, and they provide lot of, you see lot of animations, they have lot of logic on the client side. And so the way data get exchanged between client and server, if one of the factors plays very important role is performance, how much time it takes to kind of get data between from the server on the client. So if it is taking a lot of data, a lot of time, then no one will like to kind of use your web apps, and they will find it sluggish, and they will actually probably move to some other services. So it's very important to kind of work on the performance of a page, the way data kind of we have to understand and try to optimize the data, the way data is exchanged between the client and server. So server side optimization and client side, we have to kind of understand like where the optimization is can be done, whether when data is getting exchanged, where it is kind of a taking time, whether it takes time on the server, is it server taking time to kind of generate the script and get the data from the database, or the issue is on the client side. The client is not our scripts on the client side is taking too much time to process the data and render it on the front end. So it is kind of a very important to understand how the data is being kind of processed on the server and how it is consumed on the client. Usually, it depends on uh, most of the time how you've configured the web server, whether you are caching, configure the web server to cache, allow client to cache static files, uh, whether a lot of caching is being done on the server for the data which is getting fetched from the database, whether the caching, server side caching is implemented or not. So that's very important to understand. And then you have a client side optimization where you will see that you kind of your script, client side script are very uh, uh, written in optimal manner so that it itself doesn't take a lot of time to kind of render the information. For example, if you are rendering, say, list of 1,000 people, so you will try to kind of show only 20 users at a time, and rather than actually kind of a render all 1,000 students. You might be getting 1,000 students record from the server, but just to make sure you render very quickly to the front end the record of the initial student, you will just render 40, and then probably on scroll you will try to render again. So you'll show within the viewport which is available to the user first 20 or 40 records, and then based on their scroll, whenever the viewports actually increases, you will keep showing the data. So that is one way of optimizing the client. Then there is a latency issues also, why your page is actually loading very quickly. For example, if our web server or the server is within intranet, you will find that your HTTP request will render you information very quickly because the communication is happening within the intranet. But if your server is outside the intranet, then that particular to fetch the data from the server for a given URL might take more time. So that's also very important, like where your server is located, and it actually nowadays leads to a lot of concept of uh, edge servers, CDN servers, and all those things. So if you guys are familiar or working with AWS server, there are a lot of services which allows you to cache data on the intermediate servers rather than uh, kind of directly hitting the servers for all the resources. So that way they will try to kind of minimize the time it takes to fetch the data from the central server and reduce the latency between the client and browser, client and server. And of also the size of the response matters. For example, the example which I've given earlier, uh, uh, if the server takes the number of records we are fetching from the server, say we were saying 1,000. So if server actually kind of taking time to give you 1,000 records, so it's better to not to request 1,000 record from the server, but just to request 500. And then because anyway you are not going to show all the records to the front end user 500 records. So in a given viewport, you probably will be able to show only say maximum 100 records. So you'll show the 100 records, and then based on when person will scroll, you might send one more request uh, to the server and get the next set of records. So you can try to reduce the size of the payload of a request. One example of the reducing the size is, for example, as I told you, nowadays the web pages have become more rich. So because web pages have become more rich, we have come up with a lot of client side technologies which allows to be more creative on the client side. and that resulted in that writing lot of JavaScript. When you're writing a lot of JavaScript, of course your client side code size will increase. So nowadays we have a single page application. So if I've actually built a app with a thousand, say 100 or 200 screens also, then the size of the kind of an initial request might actually increase to say 200 2 MB to 4 MB of JS. And when you try to actually hit the server to kind of get the initial JS files, it might take a lot of time. But once it actually on the client side, you won't find issues with actually kind of a going to the next screen, and next screen rendering will happen fast, and you'll be in that case you'll be just actually getting the dynamic data from the server. uh, but initial load will be kind of very slow because you are fetching a lot of data from the server. Then of course you need to do lot of optimization rather than getting JS for all the screens from the server. You will try to get only for say login page first, and then subsequently you'll get try to get the home modules or a reporting module or whatever module you've done. So people try to divide their code on the client side based on modules, so that you are not requesting all the modules JS at once from the server. And of course, server is kind of a again configured to kind of a reduce the size of the files, and that has been done by techniques such as zip. And so as we know that like data is getting exchanged between the client and server in a text-based format. So when we write JavaScript and CSS, we actually indent it, and because of indentation we have single line characters and then tabs and all those things. But to the browser it doesn't matter. It doesn't need to know the next line characters or tabs and all those things. uh, if you kind of remove it, it will be happy to kind of parse it and make it work on the client side. So then again, the techniques is applied to reduce the file size of JS and CSS by removing the tabs and new line characters. That is called kind of a minimizing your JS and CSS files. And then actually then if you apply CSS and minimize your JS and CSS file and apply gzip, then you'll see the size of the file reduce from uh, 1 MB to it can come down to 100 KB as well. So that is those are the few techniques you can apply to reduce the response size. But there are other techniques on the server side as well, uh, which actually requires the understanding of the way servers are configured, the way the edge servers gets configured, and then CDN servers gets configured. So we actually try to understand what is client side and what is server side. So usually you'll be if you're doing a web development, with sometime people start with the client side and they write the client side code. They code to kind of render the front end and request the data from the server and then process it and show the required view to the client. And then you'll have a server side developer who will kind of process the request, interface with the database, and then kind of build the response and give it to the user. And then you have a database developer which will write your data store tables, store procedures and queries, uh, with which the backend developers will interface. They will call the queries, get the required data, and then build the response. And then we have a DevOps who understand how the servers are set up, how the code are getting deployed. Uh, so DevOps guys usually take care of setting up servers, deploying the code, maintaining the web servers. And in the end, you have a mobile app developers who will kind of uh, develop mobiles which actually interfaces with your uh, web servers APIs, and you might have a kind of a native app, or you have a kind of a hybrid app where more or less your JavaScript and CSS skills which you have used for front end development can be used. So usually, like, these are the specialized what you say streams, and but some people prefer to kind of work on across all these things. And when you try to work across all these things, it will surely will take some time. It's not that you can get become a full stack developer at once. You have to start first, like kind of a very basic project where you're just kind of trying to understand and understand the workflow, how server works or how client works, how to code on the client, how to consume the uh, data which is being sent by the server on the client, and how to process and structure the client side code. And then you'll move to the server side code, and then like kind of a database, creating and designing a database. Usually you can start with this, and then you can actually move to DevOps and all those things. But of course, like you have to start slow, and you have to kind of get more uh, kind of a practice with it, like, and you will become better over the period of time. And on the front end developer, you of course you have technologies like Angular, you have React, you have a TypeScript, then you have less SAS and Gulp. So less is for CSS, SAS, less and SAS are for CSS, and Gulp is for kind of a lot of uh, script to kind of package your client side code. And then you have a on the server side, you have a Django or Express.js or Node.js, Python, PHP. Then of course you will also try to understand how you can do caching in the middleware. And on the database side, you can start with MySQL, which is kind of a uh, straightforward. We all are actually, we know how to kind of write, create table, generate table. We learn that in our colleges. And then we have NoSQLs nowadays. MongoDBs are NoSQLs are becoming more and more popular. So MongoDB is one of them. And of course, like, you if you understand how you will deploy your code and how the web server will process your server side script, then it's of course it's a good idea. So getting used to at least Nginx is helpful, and see how websites are configured, how you can actually make it uh, configure it to kind of a zip certain resources, and understand how to read the logs if anything goes wrong. So you can get started with Nginx as which is the kind of a good to kind of a just get started. And then you have a hybrid app, but I think that can comes later on. So once you understand at least these three things, front end development, back end development, database, then you can actually get into it. It will come very easily to you. But this is what full stack is all about. When people say that, like, you are I'm a full stack developer, then the expectation from the other person is that you understand all these streams and you'll be able to contribute. uh, we try to understand what is full stack development, and but if you see how the development starts, uh, it's actually start with the designing phase. And to a developer who has the understanding of the design and how it should work, can really kind of bring a lot of help to the team. So full stack developers are also expected to understand certain design principles to see that they are on the right path. Of course, it will start with the designer. We'll have a dedicated designers, but if you have a developer who can say that, hey, there are certain things, the way the interaction is happening, between the two pages doesn't look right, and they can bring to their notice and kind of a suggest, that will be really helpful. So it is the first step of a development process, and it actually kind of defines how the data needs to be captured and how it needs to be communicated, how two screens will, how person will go from one screen to another screen, and then all the decisions about the product is kind of happen at this stage. Earlier, what used to be done in the waterfall model, the design used to be done at a kind of a at the beginning of a project, and then we used to get into a development and we are done with it. So that time, there was no there was kind of a no scope for a developer to kind of suggest changes or say that, hey, certain things are not happening, because people used to spend five months, 3 months, 1 year to kind of just design, and then it used to get into a development, and then design process and development process used to be really kind of a disconnected. But if you all know that, like the waterfall model is actually nowadays dead. No one has a time to kind of uh, uh, to spend such so much time that it takes them 2 years to launch the product and go to the customer, and then based on their feedback again refine it. So nowadays the people are using agile methodology to do the development. Because of that, it has become more uh, important that developer understand the design principle, and then that they can contribute. So in agile development, usually within 2 weeks time, you are actually producing and deploying a usable code uh, uh, on the production directly. So whatever you develop, whether it's 2 feature, 3 features, the team's code will get deployed on the production server, and end user will start using it. And then when end user starts using it, they gives a feedback, and then on the again, like in the next cycles, those feedbacks are incorporated. So it's not your complete products are not, it's not designed, so you are actually kind of a designing one module, uh, and very small modules, and then that requires the design happens in that particular sprint itself, or the development cycle itself. In 10 days you actually kind of a design, you develop, you test, and you deploy. So that requires developers, testers, and designer, everybody working together, and that requires like everybody understand each other's skill set, so that they can collaborate and contribute more. That's why like having this skill will really help you, and you can in true sense call yourself a, a full stack developer. So what is UX and UI? You'll always like kind of hear these terms, like you have a UX guys and you have a UI guy. So UX is about the interaction design, how person will actually kind of register on the screen, and then after registration, where he'll land up, and what messages will be shown to him, what is next step after registration. Then like they do a kind of a wireframing and prototypes, rather than actually we end up creating the front code, our code in HTML and CSS. They will first actually create some wireframe where you can interact and play. So as a developer, you'll get a wireframe, you'll say next. Okay, what is happening? And I need to actually kind of a code this now and make it dynamic. Of course, like a UX person designs the information architecture, how the information is flowing within the system, how person registers, and after registration, how he logins, what kind of a data is generated within the service, how it is stored, and then who can view that information. For example, if student, we are actually building a student, say LMS, where you can uh, log in and take up lot of assessments. So uh, so as a user, I'm logging in, and then I'll be actually kind of taking assessment, then I'll be looking at the reports. So how this information flows and what is the architecture and how it is actually stored, that has been handled at the UX level. Of course, user research and understanding what will be, how easy this feature uh, will be presented to the end user, so that they can very quickly find out what they want rather than searching and then doing multiple clicks and getting into a app to kind of get the data what they want. And of course, like scenarios in which the student end user will be interacting with the system. So for example, in the case of LMS, you'll have a end users log in and he lands up on the home page, and what should be shown on the home page when he lands up for the first time, what should be shown on this home page when he lands up after taking an assessment, what should be shown to the user on the front end when there is an assessment is due, or what should be shown to the end user when the he's taken all the assessment and course is over. So all the scenarios are actually taken by the UX person. Then UI is mainly concerned with the visual design, what typography will be used, what font type will be used, what color scheme will be used, what will be the layout, how the information will be structured, in the sense like you have a header, footer, and body. So whether we'll be, for example, for the home page of a user, whether we'll be going for a really tiled approach to show uh, the all the assessment which will do, which is due, or we'll go for the list view. What color scheme and contrast will be used. So those are the UI person's job, but both actually goes hand in hand, and they when they work together, they make the complete user experience actually get enhanced. So this particular field actually plays a lot of important role nowadays. And then having a web developer who understand, okay, there is something wrong. For example, I have taken an exam, my design says that, okay, your exam is over, but it is not telling me after that my exam is over where to go. If I close the uh, uh, say the exam over pop-up, shall I be taken to the home page, or shall I be taken to the some other page where I'll get the summary? What shall be done? It's not very clear. Then developer can actually kind of point those things, and I'm telling you because like uh, being a full stack developers actually gives you an opportunity not only to work on the client side, on the server side, it actually gives you a long view of the whole process, the way it is happening, the way data has been moving from client to the server, and the way data has been stored, the data has been processed. Because you have this understanding, you can contribute a lot in the UI UX structure, because you understand the way data is stored, and you can actually say that, hey, we are storing data this way, that's why it needs to be shown in this manner. For example, the UX UI person, if they have missed to show information about user, so assume there is an profile page, and they are actually showing a paragraph about the user, which user can type and store. But you know that in the database, the way it's been designed, you can store only 256 characters in the database. So if they are showing kind of a 500 characters in the front end, that panel, then you can say that, oh, that panel is too big, because you will never be getting that amount of data from the database. So it's better we actually reduce that panel size. It should not be more than 256 characters. So accordingly, the designer can actually improve it, or other way around, they're actually showing only 256 characters, but you know that like when it comes to entering a data, user can enter 1,000 characters. So if there is 1,000 characters in the database, your UI might not able to handle it. So then how will actually kind of a process? That's very important to kind of so that's how, because you are getting a long view of like the way data is stored and the way data is getting processed, you can definitely kind of make a lot of suggestions when it comes to the UX UI process. So I think that is very much kind of important to understand those part of the full stack development. And then you have a front end development. So I think I just try to give you a long view about like how the data is, how web works, what is the backbone of a web, how the client and server are important, then what is full stack development is all about. So you have all those. I try to give you that long view, but I just wanted to give you a deep view, like when it comes to the front end development, what it all involves and where you need to get started. So when it comes to doing a front end development, you can see that you actually kind of start with HTML, CSS, and JavaScript. You have to understand these three if you are working with the web, especially on the client side or front end. And then you have to kind of get deeper. Now you have to understand next set of technology, like kind of which revolves around JavaScript and CSS. So with JavaScript you have ECMA. You need to understand ECMAScript 6. uh, so you all know that if you are not aware of, JavaScript actually started with very kind of a basic language which was used earlier on the client side to just kind of do a basic validation. But now JavaScript are used to kind of manage business logic, do complex calculations. Uh, so because of that, still using the old syntax of JavaScript is not feasible, and JavaScript inherently doesn't help you to kind of uh, managing the large code base. Uh, for example, in JavaScript, everything is var, and if you are making a type-based mistakes, then it will kind of just crash or like show a runtime error. But of course, you don't want to do that, and because of that, people started kind of improving the JavaScript, and then a lot of development happened to uplift the JavaScript from where it was kind of a 5 year backs or 8 year backs. Now it has, every year you get a new JavaScript enhancement version. So at present we have ECMAScript 6, which is kind of a standardized version, which is mainly kind of a used. And but your browsers are using ECMAScript, still using ECMAScript 5. So your browser doesn't suppose ECMAScript 5, but you have ECMAScript 6 available. But browsers are running ECMAScript 5 only. So what people have done is like, okay, the browser are not ready. That's fine. Let's do one thing. We will write ECMAS. We will allow people to write their code in ECMAScript 6 so that they can maintain their complex business logic, uh, and uh, provide better structure for coding. So they actually come up with the ECMAScript syntax, and then they actually compile it, and then ECMAScript 6 code get compiled when you are actually building your. So earlier people used to write their JavaScript code and then they have a JS and CSS file and they used to kind of just deploy it on the server. But now on the client side also you are now building your client side projects. So you build your client side project. What does that mean? Your ECMAScript code will get compiled into a ECMAScript 5, uh, which is kind of a ready to be deployed on the server and can be used by the client. So if you just like if you write a JS and in that you have ECMAScript 6 code and you just deploy that file on the server, it will be fetched on the client, but client will be fine will won't be able to process it because client all the browser doesn't understand all the ECMAScript features. Similarly, so ECMAScript 6, that's why you have the TypeScript. So TypeScript is actually allows you to write code in the structured manner, and then when you compile it, actually spit the JavaScript code. Uh, so on the JavaScript side, you have further building tool. As I said, like you need to build your client side projects now. So you have npm scripts, gulp, and grunt. So they are a task runner, which actually you can do say that like, okay, take this file and then actually compile it, minify it, and then put it in this file. So you can do that. And then you have a package manager. So now earlier, like as I said, like it was a very JavaScript was not used for writing a complex code, so you never needed to kind of uh, manage the packages. Now you have a you will write to people are writing a lot of reusable JavaScript packages and deploying it, and then distributing it using npm. So you will find a lot of libraries, npm libraries available, which you can directly use in your code, and you don't need to kind of write a lot of things. It is more or less, you can try to, if you have worked with on the server side, you understand DLL. And if you work with C++, so we used to have a DLL which can be kind of used on the client side, and it's a kind of an independent project, but can be reused. That logic can be used in other projects. So you have a packaging tool npm which helps you do that. And because you're writing a lot of JavaScript, you need to do a lot of write tests also. So so that your JavaScript are not kind of or the client side code is, it's not something you just do testing from the front end. So you have a jest and mockup which helps you to writing a tests for the client side. And of course you have a frameworks which helps you to kind of get the job done quickly and get you started very quickly, and helps you in write a code in a structured manner. And two of the most popular frameworks are Angular and React. There are others as like kind of but like these are the two main popular one. React is becoming more and more popular nowadays because of the flexibility it provides over the Angular. And of course, like when you are working with this, you'll be actually, you need to maintain the state on the client. So uh, for example, if you update one particular data store, you might want to uh, based on the data value get updated, you might want to update the UI front end two different divs. And you don't need to kind of then do this programmatically. You can do it via state management services, and those services can actually trigger and update the data in those views. uh, and then of course, like module load and bundler are webpack, which can help you to kind of bundle the modules in a given set, so that on the client side you don't load all your JS and CSS on the home page itself. And on the CSS side, you need to understand how to write a responsive web page, what are the media queries. And there are CSS frameworks which are kind of can help you to get started very quickly. You don't need to write a lot of codes from the scratch. And Bootstrap is very popular. And then of course the story of JavaScript, it was kind of a very difficult to manage large code base, comes with the CSS as well. So CSS used to kind of write the colors, which is primary and secondary colors of your font. People used to write again and again in all the classes. And that was actually kind of so if tomorrow if you want to replace those colors, you have to go and replace all CSS, like all the 100 CSS classes. So people are actually kind of started thinking about there also as a preprocessor, where it will allow you to write a CSS code in a more structured manner. and more manageable manner. So SAS is one of the CSS preprocessor which you can learn, but nowadays there is an effort to add a lot of those CSS preprocessor in the CSS itself. But again, like those features are not supported by all the browsers, and because of that, we have to rely on the preprocessors to make sure that we cover variety of browsers across multiple platforms. Uh, I think with the CSS, as a like when it comes to responsive layout management and all those things, you have to understand. Uh, they're also like they have come up a lot of methodology of like how to write a CSS. So there is a object oriented CSS writing a strategy, and that's there and interesting to know that you can actually kind of learn about it. It can help you to manage your CSS code in a better manner. And then you have CSS layout management. You understand grid, because if you don't understand grid, writing responsive web page is not that easy. And of course you have a flex box and other way to kind of manage your CSS and UI. So gradient transformation, if you want to click off a button, you want to kind of do some animations, those can be easily done with transformation and transitions. And of course scaling up, scaling down, rotation, all those things are now kind of popular possible with CSS. Again, like with CSS, you need to work a lot of libraries and which can help you to render complex UIs. So you can understand, like you try to get and understand these libraries which can help you with that. So that was front end development. This is where how you get started with HTML, and then you kind of master your CSS and JavaScript skill, and then there are other kind of services which can help you in actually kind of managing your code. For example, if you start with Angular and then you might not know Angular behind the scenes are actually using like a Webpack to an npm package and all those kind of a thing. Of course, like if you're writing a hello world, you won't know, but when you write a more complex logic, you really need to understand that and might need to tweak and uh, kind of make it work as per your project. So that was front end. And then of course, like coming back to the back end. So on the back end, it's actually kind of a start with the primary. Just a second. It start with the uh, like a server side scripts. You write server side script, and just a second. Yeah. So you start with the server side script. So you make a choice like whether you want to go with the Ruby or Python, Node.js, PHP, whatever you want to kind of. You have to pick up one stack to get started. It's not you don't try to master all the stack. If you understand one, of course, like transitioning from one step to another, it becomes easier. Why it becomes easier? Ultimately, the communication happening from the between the client and server is happening through HTTP protocol, an HTTP protocol standard. And what is the backbone of HTTP protocol? The way communication is happening is through request and response packages. So if server is actually requesting, actually processing certain request, it needs to understand how to process the request, how to see that like a URL is actually kind of a now with you, whether user, which user is this, how to process the data which has been posted to the server, how to kind of process the query strings which is posted to the server. The concept is same. Of course, the syntax will differ. How you do in Python, you might be able to do it couple of lines, and you might need to write more lines and when it comes to the PHP, but the concept is same. You'll ask how to process the request on the server, and then you'll see that Ruby does it different way, Python does it different way, Node.js does it different way in terms of syntax. But all they are doing, they are actually kind of a giving you syntax to read data from the response package which has been submitted. So you have the request response uh, APIs will be there in all the server-side script. How you will interact with the IO will be there with all the server-side script. How to connect with the database will be there. So you once you actually do this cycle with one particular language, it's easy to like you kind of go from one language to another if the demand comes from the project. No, now the client might come and say that hi, due to XYZ reason, we have invested lot in Python, so we'd like to do this in project in Python. Of course, like you can get up to speed with the syntax, and then you know all the concept. Okay, I need to kind of process the request. I need to kind of write file to the server. I need to kind of read file to the server. I need to kind of get data from the database. I need to kind of write data to the database and all those things. So those concepts remain same. Uh, but I think lots of web concepts which are getting used nowadays in other projects and other frameworks on the server side are getting kind of implemented, that was kind of introduced in Ruby. So in Ruby on Rails, they have introduced lots of concept of like design pattern. So they were the first to introduce MVC design pattern, and then they were the first to introduce the concept of what you say uh, ORM techniques, where you need to kind of doesn't need to write a script, database script, and internally your objects actually kind of translates your creates your query and hit the database. They were first to do it, but other like kind of a Ruby on based on Ruby on Rails, other uh, frameworks are trying to pick up. So you actually start with any whether Ruby on Rails, Node.js, Python, or PHP. When you're working with Node.js, of course, you'll get started with Ruby on Rails, and then Ruby on Rails has Ruby Gems, which is a package manager. DLL reusable codes are there, and if you want to do a kind of a testing, then there is RSpec. And Node.js, of course, like you'll have a package manager, you'll have a framework, you'll have a testing. So Node.js, people go for Express. Then you have a NPM package manager, which is like you have on the client side as well on the server side. So Node.js is basically a JavaScript, which is kind of running on the server. And then you have a testing. So you saw that Jest and Mocha were there on the client side. You can reuse on the server as well. So nowadays, that's why people prefer to kind of learn one language, that is JavaScript, and then get it kind of a hello. So yeah, so you will actually kind of you have a package. Sorry, so you have lots of people are actually kind of using JavaScript only, and then like you are not kind of saying that okay, I need to learn a JavaScript for the client side, but on the server side go for Ruby and Rails. So people who are starting, they are saying okay, let me actually get used to one language and get it started with the server side as well as client side. So you can actually do that as well. uh, of course, like writing Node.js on the server side, because it's not traditional, there are certain things you need to understand, certain different techniques. For example, JavaScript is something, it is not blocking and synchronous language. It doesn't actually, if you send a request to the server, you are writing a line wise code. So you're saying hello world in first line, and second line you are actually sending an Ajax request to the server to get the say list of people. So that request which went to the server is not synchronous. You have sent the request to the server, and then JavaScript interpreter won't wait to kind of get the data from the server and render it and then execute the next line. So if you've written first line hello world, second line Ajax request, third line you are writing say how are you doing, then in between you are trying to kind of render the list, then it might happen you will see that in the front end You have written hello world, you have written uh, how are you doing, and then like a list actually get renders after like these two items get rendered, so it's not blocking. So you need to understand how to write that kind of a code and make sure that it is synchronous. So there are a lot of techniques of callbacks and all those things you need to learn when it comes to the JavaScript, because JavaScript was never meant to be kind of a written that way, but now people started writing, so it has its own issues which people are trying to address to write the complex code. That's why you have ECMAScripts and other things. Then, of course, the PHP is very popular, very lot of reusable code, lot of kind of uh, libraries are available which can be used. Symfony and Laravel are very popular, which is used by people. Then .NET is actually picking up slowly, but actually it is because it's become open source and it can run on not only Linux or Windows, but I think on the Unix also. So it can run up on the platforms. You don't need to kind of deploy for the development purpose. Also, you don't need to kind of have a Windows machine to kind of start doing development on .NET. So .NET Core is kind of a platform agnostic and can run on any platform. That is the case with all the languages, for example, Ruby, Python, PHP, Node.js, and of course Java was there, which was platform agnostic. So now .NET Core has become platform agnostic. It comes with a lot of benefit of the .NET world, and uh, it's become slowly popular. So you learn the languages which you want of your choice, and then based on that, like you go for their frameworks which you'll be using. So for Python, Django is actually very popular, and of course those all of them actually have the features of uh, uh, it's not like you can do certain thing in the one language and certain thing can't do certain thing in other languages or the framework. So more or less these frameworks are getting rapidly and uh, catching up with each others. In terms of leaders, like Ruby on Rails actually introduced that concept of uh, MVC, ROM techniques and all those things, and how to build process and everything was introduced first by them. Then, like, of course, Django's was there along with Ruby in terms of that, and other frameworks have actually kind of started catching up, and all those concepts are available now in uh, all these languages. So sometimes it becomes a matter of like a choice to go for which particular framework on language rather than a strategic decision, because at the core they are all open source. They provide all similar features. That's why uh, it's better to kind of learn the concept and be open to kind of shift to the language as and when you want. Uh, so if you're doing a server side, of course, you need to kind of understand these concepts, which will help you uh, kind of work efficiently on the server side. You have web server, understand how to configure the web server and deploy your server side code there. What is JW2, when how the authentication now is done. So I actually told you traditional authentication with the states server and cookie based authentication, but now we have OAuth and then JW2 token based authentication. Of course, people are now writing a RESTful services uh, because a lot of logic is on the client side, and your service kind of can be used with the various clients, single services. Your various kind of designing strategies of keep it simple and kind of a solid. Then you have a regular expression. Of course, you should learn like how to write a regular expression. Otherwise, you'll do the same things in a kind of a. You might need to write a lot of code to do the same thing. GraphQL is something comes up very become recently very popular uh, uh, on the React stack. So people are writing a GraphQL which will help you. to kind of interface with any database and services and render the data rather than you are actually kind of querying the data. So principle of GraphQL comes from very simple thing. You have written a database query and database used to give you a data in a structured manner. So if you have a first name, last name, and say first name last you want to request a record of a person, so you have a first name, last name, age, these three fields. So you'll write select star from this and get this data. So the server will give you that data only. But if you want to kind of say again request a data for address, then you will write again one more query, or you will update that query to give you again that data. But the way GraphQL gets configured, it actually gets configured from the scale. It is directly interfaced with your tables or API, and based on what the client asks at runtime, it actually fetches that particular data. So your server side becomes more extendable, reusable. So you don't need to go frequently and change your server side to get the same data from the same record, same entity, different record set. So you don't need to say that like, okay, I need to write one more query to the server to get additional data. You have only one endpoint person, and you will say from for person, give me first name, last name, and then second same endpoint person, you will say give me first name, last name, and then age. So that is the principle of GraphQL. Then you have a Docker. Docker is actually uh, it is becoming more and more popular, not only for deploying the services but for development purpose also. How often we have actually kind of we get we kind of a developer tells us, oh, it is working on my machine, or development environment has been set up on my machine, it's running fine, but I'm finding to kind of set up the development environment. So the when you actually go and try to search what is Docker, people will try to explain you from the point of view how it is different from VM and virtual machine, and how it is not virtualized and containerized and all those things. But why it is kind of getting used, because the same environment which you have set up, you actually push those environments. So whatever server you have created, uh, you will create that, say you have configured nginx and then you are running. So that containers is being configured to run the nginx and your server side code. And that server, if it is running on your PC, that particular container you can package, and you can actually push that container to a repository, and then from that repository, a container, any person can fetch the containers, and then 100% of the time it should run out of the box the way it was running on your machine. So the concept of the Docker is concept of actually sharing the complete development or deployment environment from developer's machine to the production. So that is why Docker is actually kind of becoming more popular. Often, like organizations spend a lot of time to set up the development environment. So if new person time joins, so then, oh, we need to set up his development environment. So he'll go through the list of things. Okay, install this, install that. This is the dependency. That is dependency. But if you have a Docker in place, you have a containers which is there, and then you can tell him, hey, go pull that container, and then for the code, you actually interface with this repository and pull the repository from there, pull the container for the development environment there, and you should get started and running in couple of hours rather than 3 to 4 days. So that is the power of Dockers, and becoming more and more popular. When you, if you're in industry, you'll or when you go to industry, you realize uh, people's development environment will now set up in that sense. And then Dockers, of course, like is used to deploy, if you're on this to deploy the solutions rather than actually deploying everything on the monolithic servers or a virtual machine. They actually deploy Docker containers, and if needed, they can increase the services, create the copy of the same service. So, for example, you have a service to deliver just a static file, and if you see a lot of requests coming from the static file, you can actually kind of deploy more services there and load balance it. So then the Kubernetes and all those things comes into the pictures. Uh, uh, because of that, how you orchestrate it and Ansible script and other things to kind of create the Docker image, and those concepts are there. But I think just to give you top level things, it is good to kind of get used to the Docker, because moving forward, your server will be Docker based, and your development environment will be Docker based, more or less, for the all the new projects which is kind of coming in. Uh, so then you have like message broker. So we all talk about database and all those things, but it's not like from the point of scalability, it's not that like you should be hitting database directly. Database might be busy, so rather than using your like request, you will post the request in a queue server, and from that queue server, the data will be periodically kind of fetched and processed. So if the data doesn't need to be processed immediately, so people actually maintain the queue, uh, and then message queues and then use that. And of course, the caching is very important. Database, actually, when you are communicating with the database are storing data in a on the disk, and when you query, it is kind of a brings the data in the memory and then gives to you. So the data processing takes time in that sense. And of course, like your database uh, is not that much scalable, because it, for small things also, you need to go and kind of query the database. So people have concept like session earlier, but session is kind of a stateful, so people started kind of making it stateless. That's why people are coming to something called memcache and radish, which are storing very kind of a small data in a memory. It's not like they are supposed to cache major data, but small data in a memory they store. So knowing memcache and radish, I think, is a good. And then you have a relational database. You can get started MySQL, Postgres, whatever is there. And NoSQL, MongoDB is more popular when it comes to NoSQL. And of course, like when it comes to uh, uh, search, you won't be actually kind of your SQLs and relational database NoSQLs are not meant to kind of give you a kind of a search result. So nowadays there is a lot of demand to have a good search engines. So this is where the Elasticsearch comes in the picture, which actually interfaces with your underlying database is, and then can actually help you to do a lot of Google-like search. Otherwise, from the database, you will like kind of a search you can do, but you won't be able to kind of do complex search. This is where you can actually learn Elasticsearch.
Thank
All
you.
right. Yeah. All right. Thanks. Take care. Bye.
Yeah, bye.